I want to do example problem number 32 out of the textbook here. The directions are to convert this integral into polar coordinates and then evaluate it. So there's a couple things I have to do here. One is I have to change the limits of integration, and the other is I need to change the function, and well, three things, because I need to change the function and I need to change the dA. The function here is the square root of r squared, so that's just an r. Right? X squared plus y squared is r squared. Square root of that is just r. The dy dx, or the dx dy here, this is dy dx, but either one would convert into r dr d theta. So this is going to end up being an r squared. I should point out, though, now that I see this, that I've seen people write it this way. Looks really weird to write it this way, but they take one of these r's and they put it over here. So they write it as r dr r d theta. This is the pirate way of doing it. Anyway, now I need to convert my limits of integration here, and in order to do that, I need to look at the region. I got to see what it is I'm looking at here. So I'm looking at this. X is on the outside. X is between 0 and 2, and for every value of x in between 0 and 2, y is starting at 0 and ending up at this function, whatever it is. A couple things I noticed. I'm just going to draw a quick sketch of this function. I noticed that if I plug a 0 in there, I get 0. And if I plug a 2 in, this is 4 minus 4. That this is like this. And then I'm like, wow, at least it's starting here and ending there. How would I convert that? Well, this is the equation. Y equals the square root of 2x minus x squared. If I square both sides, I've got y squared equals 2x minus x squared. Bring this over to the other side. I've got x squared plus y squared equals 2x. All right, now it's looking more like a conversion to polar here. This is r squared equals 2r cos theta. And if I divide both sides by r, I've got r equals 2 times the cosine of theta. Right. So that right there is r equals 2 cos theta. Okay. And so what I can see is this region now, which is apparently half of a circle. Right? Is that obvious that it's a circle? From here, you could, if you bring the 2x over and complete the square, it turns out to be a circle. We can review polar coordinates if you need to. But what I notice is that this region that I'm interested now in is completely contained between 0 and pi over 2. And that for every value of theta in between, r starts at 0 and ends at that curve. Every single direction starts at 0, ends at that curve, starts at 0, ends at that curve. Okay, so that's telling me that theta is between 0 and pi over 2, and that r is between 0 and 2 cosine theta. Okay. Now, I can integrate this. I've got the integral from 0 to pi over 2. That's an r squared. Integrates to r cubed over 3. Evaluate between 0 and 2 cos theta. And then d theta when you're done. Actually, you can do the d theta now. No, never mind. I was thinking you got a rectangular region, but you don't have a rectangular region because that's not a constant. That's not a number. So I've got the integral from 0 to pi over 2 of 8 cosine cubed theta over 3 d theta. And yeah, I could do it by hand, but I'm not going to. I'm going to break out my handy dandy calculator and see what I get. Function int 8 thirds of cosine cubed x, comma 0, comma pi over 2. Enter, and it says 1.777. Okay, so that's 1 7/9 apparently. Yeah, there you go. What's the process? The process is I needed to convert the function. I converted to an r. I needed to convert the dA, which is r dr d theta, and I needed to convert the limits of integration. In order to do that, I draw a picture of what region is being described in x's and y's, and then I say, okay, what values of theta are involved here? And for each value of theta, what values of r are involved? Okay. So there you go, number 32.